Welcome to all of you. In this lecture, we are going to discuss about the 7490 decade counter. This diagram shows a typical 7490 pin diagram. It consists of 14 pin and internally it is going to have two counters. First one is a 1-bit counter, second one is the 3-bit counter. So since there are two separate counters, there will be two separate clock inputs we can observe. Also, this decade counter is known as the BCD counter. That means it can count in the range of 0 to 9 total 10 values ranging from 0000 up to 1001. It can also be designed as a mod counter. Now let us get into the internal representation of 7490. As I told you before, it consists of two internal counters. So this is the first counter, that is 1-bit counter, also known as the mod 2 counter. One more is the 3-bit counter, also known as the mod 5 counter. Each individual counters are going to have separate clock inputs. That's what we can observe. Also having the independent outputs. So this is 1-bit counter, therefore it's having only one output. This is a 3-bit counter, therefore there are three inputs. In order to control these two counters, there are four asynchronous inputs. That is MR1, MR2, MS1 and MS2. MR represents the master reset. MR1 corresponds to the first counter. MS1 also corresponds to first counter. MR2 and MS2 corresponds to the second counter. So MR stands for master reset. MS stands for master set. These are asynchronous inputs. That means whenever this has been activated, it will directly reflect on the output without any clock pulse. We will have more discussion about this during the functional table representation. Now coming to the functional table. The MR as well as MS are the asynchronous inputs and they are active high inputs. Active high in the sense when 1 is being given for them, they will reflect its action on the output. When 0 is being given, then it will be inhibited. Since they are asynchronous, they don't require any clock pulse for activation. Therefore, whenever we are representing the functional table part with respect to MR and MS, we say clock is don't care. Now let us go through the table. So these are the inputs and these four are the outputs. Q0 is the LSP bit, Q3 is the MSP bit and these are the remarks. Now, so clock is don't care. MR1 and MR2 are equal to 1, 1. MS1, MS2 are 0 and don't care respectively. In such case, this is master reset. Reset in the sense make the output equal to 0. With respect to both the counters, master reset is equal to 1. Therefore, from both the counters, the output will be set equal to 0. So, output is equal to 0. We call that state as the reset state. Then, once again, there is same combination, but don't care position over here has got changed. In this case also, this is a reset state. Now, MR1 and MR2 are don't care. Both of MS1 and MS2 are equal to 1. So this is called master set. Set in the sense set the output to the highest value. Since this is a decade counter, the highest value is equal to 9. Therefore, the output will be set equal to 9, that is 1001. So set to 9. Now, when we want to make the regular counting operation, that is a sequential count, in such cases, this must be one of the combinations with respect to master reset and the master set. And then as and when we keep applying the clock pulse, the regular count operation is going to happen. Regular count in the sense, if you start from 0, then 1, 2, 3, 4, like that it will reach the highest value. Then after highest value, it will again go back to the value 0. This is what we say the regular count operation. So remember, any of these can be the combination of the master reset and the master set to perform the count operation. Now, for the sake of remembering as well as the rig up the circuit for operational purpose, let us simplify this functional table. So where all there was a don't care term, I have just placed 0 over there. Now let us make it more simplified version. So this is what is required for you to remember whenever we are working with the circuit. So very simplified representation I am going to take, but don't take this as the complete functional table. This is just for remembering as well as working with the counter. Now with respect to reset state, keep MR1 and MR2 is equal to 1, MS1 and MS2 is equal to 0, then it's a reset state. Then make these two is equal to 0, MR1 and MR2. Keep MS1 and MS2 is equal to 1. Obviously, this will be a set state. Keep all these as 0 and then apply the clock pulse. Then it will be a regular counting operation. So this is what we usually follow when we rig up the circuit. Now let us get into the complete counting operation, that is the decade counter. So this is the truth table for the decade counter. It starts from 0000, then sequentially 1, 2, 3, 4 like that. So this is the last count value 1001, and then after if we continue applying the clock pulse, then it will become 0, and then this cycle will keep repeating. Now coming to the circuit representation, the understanding of the circuit. So this is one counter, this is another counter. So obviously there is two separate clock pulses. This is one clock pulse and this is one more clock input to the counter. And outputs, these are the four outputs. As I told you before, Q0 is the LSB bit, Q3 is always the MSB bit. Now coming to the circuit rig up. So this is the basic part. Now coming to what we need to keep with respect to master reset as well as the master set. So remember the functional table. In order to perform the counting operation, regular counting operation, when we apply the clock pulse, both master reset and the master set must be set equal to 0. So make it equal to 0 in the sense it is as simple as connecting all these four to the ground. Ground in the sense input is equal to 0. Therefore, all these four are connected to the ground. And then the clock is connected to the clock input. The clock input can be a monopulse or the 1 Hz clock available in the trainer kit. The second step of the circuit rig up. Now this is the second step. In the second step, we must have a clock input to the second counter also. So it is always output of the first counter will always act as the input to the second counter. Whenever we are designing any counting operation with respect to 7490, this will be a common connection that we are going to have. The output of the first counter will always be the clock input to the second counter, because this will be a regular clock pulse that we are applying to the first counter, and output of the first counter is nothing but Q0. If you observe the Q0, it is 010101, so it is nothing but a clock pulse. Therefore this can be applied as a clock pulse, and this configuration is now, if we observe, counter 1 and counter 2 are now in the asynchronous mode of connection. That means output of the first stage, if we connect it to the input clock of the second stage, then we consider this as the asynchronous mode of connection. So now this is working in that particular mode. Now the connection is completed. Here you can observe the functional table, simplified functional table representation. So if you want to perform the regular counting operation, set these 4 is equal to 0. That's fine, grounded, job done. So this is external clock from the trainer kit, job is done. Then output of the first stage is connected to the clock of the next stage of the counter. So that is also done. Now it is going to act as a normal decade counter with Q0 as the LSB and Q3 as the MSB. So this is what the truth table we are having for 7490. One thing you must remember with respect to any of such configuration. By hearting these circuits will never give you how to make the configuration. Always try to understand the working of that particular IC or how it is being represented and why it is like that only. By this understanding only, we can configure to work this with any count values, either a regular decade counter or as configuring it as a mod counter. So try to understand this simple logic that it consists of two counters. Then we need to perform a simple decade counter, which is the LSB, which is the MSB. Then make all this set and reset inputs to 0. Then job is done. It's a simple connection and simple understanding that we need to take care over here. Thanks for joining.